Yeah, so good day everyone. My name is Engineer Shehu Isadabisi, and you're welcome to my YouTube channel. Um, you're welcome to the YouTube channel of Siafat Consult. So we actually train and teach structural engineers. We teach graduate engineers. We teach um, we teach students the principles of structural designs. We actually make it very easy and simple. So my name is like I said, my name is Engineer Shehu Isadabisi, and I'm the lead structural engineer for Siafat Consult. I got a message from a friend of mine that I should show him how to use Beamax to design a cantilever, be it a cantilever beam or a cantilever slab, anyone. So and but today I'll be showing you how to use Beamax to design a cantilever beam and also a cantilever slab. But this one, sorry, a cantilever structural element and also a cantilever structural element and also a simply supported beam also. So let's begin with this example. So this example is actually going to be gotten is actually gotten from this textbook. So we are going to model this on Bmax. Then we are going to compare the result of the moment to see if the result we got from Bmax is actually the same result as what we have in the textbook. Then we'll also be doing a very simple example on simply supported beam. Then then I could end the video from then. But very soon I'll be doing design of raft foundation, and I'll also be designing a complete two-story building or one-story building. I've not yet decided it with STAAD Pro. Yeah, so we are going to start from the structural framing. From the structural framing, we go to the modeling. From the modeling, we go to the analysis. From the analysis, then we go to the result. Then from the result, we go to the detailing. But I just want to show you guys how to use STAAD Pro to actually design a structure from the start to the finish. So I've done that of PROTASRTRUCTURE. That was the one I said I actually tagged structural design of a semi-detached building. So this one I'll be using STAAD Pro for, like, let's say a two-story building or a one-story or a one suspended floor. I've not decided yet, but it might probably be like two. So now let's begin now. So so this is the free body diagram of what we have, right? So now let's go to Bmax now to now model this. Then we can now compare our results to see if what we modeled actually satisfies the moment that was gotten in this textbook. So let's go to Bmax now. So we go to new. Then now let's check what we have here. Let's check what we have here. So what we have here is okay. The span of the slab, because this is a cantilever slab. So the span of the slab is what is 1.2 meters. So is 1.2 meters. So we go to Bmax, then we try and model 1.2 meters, right? So of course we know that a cantilever slab is fixed at one end and is free at the other end. So let's fix it at one of the end. So this one is for fix, so we fix it at the left end, right? Then let's check the UDL. So the UDL here, because if you look at this structure, it's actually having a UDL and is also having a point load. So the UDL is 10 kilonewton per meter, and the point load is what, 16 kilonewton. So let's model the UDL and the point load. Now let's go to Bmax. So let's model the UDL. This is that of the UDL. So the load position is 0. The load length is what, is 1.2. The load value is what? Is 10. So we click on 10 and then we click on OK. So we have this, right? Then remember that we have a point load also. Now the value for the point load is what? 16 kilonewton. So we click on this. This is that of the point load. Then the load position is what? Is at the end of the 1.2 meter. So the load position is actually going to be 1.2 meter. Then the load value is what? 16 kilonewton. So we click on OK, right? So let's now check the value of the moment, and then let's compare it with what we have in our textbook. So if you want to see the values, you click on this. If you click on this, okay, sorry, this is not supposed to be 15. This is supposed to be 16. So let me delete this. So we click on this. So we have what? 1.2, then we have 16. Okay, very good. So what we have here is what? Is 26.4 kilonewton meter for the moment. Now let's go to the textbook now and check the value of the moment that we have. So the value of the moment that we have is what? So let's check. So you can see that the value of the moment you have is also 26.4. So that is how to model a cantilever using Beamax. But that question, the as in this that my friend asked was said he said I should show him how to use Beamax to actually analyze a cantilever slab or beam. So but I just want to go further to show you guys how to design how to use Beamax to actually design a simply supported beam also. So this thing, let me do something. I mean, let me just create a simply supported beam on my own. So let me bring out the snipping tool. Let me bring out the snipping tool. Okay. So let me just, yeah, I just want to create. Of course, we know that a cantilever beam is this thing WS squared by 8. So this that one is not an issue. Okay, so let me create this now, right? So I have this, right? Sorry, this thing is not straight, but I believe you get what trying to do here. I believe you get what I'm trying to do here. So you have a UDL here, right? So this is the UDL. So let me say this one is 6 meters. Yes, 6 meters, right? And let me say this one is 20 kilonewton per meter. 20 kilonewton per meter. So this is a simply supported beam. So of course we all know that for this is what is W all squared divided by 8, right? So let me bring out my calculator now. So we have L is what? 6 squared. 6 squared, which is what? 36 times what? 20 divided by 8, right? So let me press the calculator now. So we have that's 36 times 20 divided by 8. So let me bring out the calculator. So let's go 36 times 20, yeah, divided by 8. Okay, so the moment is I hope I okay 36 times 20 divided by 8. So the moment is what? The moment is so is 90 kilonewton meter, right? That is the moment. Okay, so let's see what we have in Bmax. So let's go to Bmax now and let's see. So let's go. So remember the span is what? 6 meters. Yeah, so we hinge at the left 0. Then we also have 6 meters. But we also hinge at the right also. We have 6 meters. Okay, sorry. Let's do it again. So you have 6 meters, right? So we hinge at 0, and we also what? Hinge at what? 6. Okay, very good. Nice. Now okay. So we have a UDL of what? We have a UDL of what? 20. Then we have 0 to 6. So let's click this. Then let's check. So you see that it is 90 is same thing as what I got here. The same thing as what I got here. So that is basically how to use Beamax. That's just basically how to use Beamax. So we have 90 kilonewton this the meter here, and this one also I also got 90 kilometer 90 kilonewton meter. So don't have any reason not to know how to use Beamax. Beamax is actually very good if you just quickly want to check what the software gave you. You just want to do like a very quick check, just like an analysis check, just to see that okay, this can be. Then just quickly use Beamax, just draw the free boundary diagram, you input it, and you get what you want. So like I said, subsequently I will actually teach you guys more. Thank you very much for joining.